Space junk is formed by technological waste from satellites and fragments of meteors orbiting the planet. It is useless material that has been accumulated and rotating since the launching of the first artificial satellite in 1957.
These objects come from satellites or meteorites that have exploded. In other cases, they owe to different issues.
Nowadays, satellites are a key factor on global trade. They are useful to provide us meteorological or climate data. Thanks to the communication and information they provide us, we are able to live in a globalized world. The means of communication satellites participate on, among others, are radio, telephony, television. They also play a crucial role in the supply of internet connectivity, which is sometimes useful in financial markets. Finally, and the most important characteristic related to global trade, satellites allow the proper operation of GPS systems, which are essential in the transport of supplies through road and through sea. World shipping fleet accounts for more than 90% of global trade. About 1,500 commercial vessels crisscross the globe every day, so its tracking is very important. Exact Earth is a company that can track the transport vessels wherever they are by satellites. Through these instruments, this company can register fuel efficiency and expected arrival time, for example. This has benefited a lot the sea transport trade.
We are overusing space, and it exists a risk of making low Earth orbit unusable because of the overpopulation of debris and the resulting collisions. The direct risks for humanity are today small, and there have been few awful collisions, even if they are increasing year after year. To date, no incidents of human injury or significant property damage from re-entering debris have been reported throughout the entire space age. Nevertheless, many satellites fall back towards Earth due to atmospheric drag and solar irradiation pressure. Some components then burn out and then survive the re-entry into the atmosphere. Then they tend to fall into a definite area in the Pacific Ocean called spacecraft cemetery at 4,000 kilometers from New Zealand, which makes the access to the point quite difficult and therefore of low danger for human activities. Some of the most famous spaceship remains are found there, as the Mir space station. It is estimated that between 1971 and 2016, 263 spacecraft were put into these waters. The economic and environmental losses can become overwhelming and join the plastic islands.
The space is infinite, but our orbit is not, and satellites have a defined lifespan. The functional orbit where these are located has been increasingly filled with space traffic, partly due to space debris. These objects can stay in orbit for even millions of years. At each impact, new fragments are generated, increasing the number of these collisions. Even tiny paint flakes can damage a spacecraft when traveling at such high speeds. Thus, it's an open spiral that provokes nothing but dangers and space contamination. Currently, there are two solutions to deal with this: return them to Earth, or to take them to the Sentry orbit where the inactive satellites cannot damage the active ones.
So, who must pay for removing debris? Little action has been taken so far, and according to the economist Peter G. Alexander, even in the absence of new launches, the amount of debris will continue to grow over the next 200 years. A few solutions to aid in the international efforts are: 1. To track them to lower orbit so that they sooner or later fall into the atmosphere and burn out. However, only the largest space objects, around 18,000, can be catalogued and tracked, and meanwhile, spacecraft have to maneuver to escape from collisions. Moreover, global warming reduces the capability to drag on space debris. 2. To place a $1 tax on every GPS chip on a smartphones, as they are a common product among global population, and that would help to collect easily money to clean up the space. 3. To fee new special launches up to 5% of the launch costs to finance the special debris cleanup. 4. Also, a Japanese film tried out this year a new product based in traditional mechanisms for collection, a 300-meter special fishing net that had to return to planet but failed in orbit. And finally, improving the satellite's technology to reduce costs and the volume of debris. One of the more immediate breakthroughs that we're already seeing are small satellites, as those of Planet Labs.
Over the last years, lots of small satellites have been launched out of space. They serve as test beds for the development of new space technologies and as hands-on education tools. For space exploration, small satellites can provide efficient and economical means to identify regions of interest before sending larger space systems with more instrumentation. The proliferation of these satellites will increase the next decades because of their reduced costs and volume. Planet Labs is a small North American company born in 2010 in California. Their satellites, sized as a shoebox which weigh 4 kilograms, are being sent to space every 4 months to image the Earth's surface daily. These pictures can be from rising environmental alerts of the first station to maritime control of shipping trade. Nowadays, Planet Labs is the largest commercial operator in the world in their field. It has launched 156 nanosatellites but plans to multiply this figure by 5 in the next years. Their satellites orbit above 400 kilometers from Earth, which is really low in comparison to the orbit of other satellites. This fact implies an easier degradation, and they re-enter the Earth after 3 years. Thus, with Planet, the problem of debris takes no more place, and consequently, the space environment is conserved. Governments haven't been investing much in spatial debris removal as the private sector. Firstly, because it's politically sensitive. A satellite, even a dead one, remains the property of the people who launched it. Thus, people cannot put objects out of sky, even if they pose a danger to their spacecraft. Secondly, there is an obviously military side to all this. If you have the capability to push a dead satellite out of orbit, you could use the same method to take down an active one.